The VIC switch was manufactured in 1983 by Handix Software in Sweden and enabled up to 8 Commodore computers using the serial port to access multiple daisy chain devices such as disk drives or printers. So, let's open it up, renovate where needed, and review this VIC switch to see if and how it works. The VIC switch has a metal base and separate metal cover, which can be opened up via 4 screws, 2 on each side. Lifting the lid on the VIC switch and removing the 6 screws securing the circuit board, we can see an array of LEDs, 6-pin DINs, and 14 integrated circuits from hex inverters, decoders, binary synchronous counters, buffers, and mono-stable timers. To help remove 40 years of grime on the circuit board, we're using rubbing alcohol and contact cleaner for the DIN connectors. And for the base, we'll remove that Velcro strip, clean it up, and replace those rubber feet with colour coordinated ones. Carefully placing our circuit board back into the metal case and realigning the LEDs. Our final task is to label the 8 input DIN connectors and the power. Having restored the VIC switch, it's now time to turn our attention to the devices. So first up we have a Commodore 1541, an Accelerator Plus, and an SD to I EC. For multiple devices operating in series, each device requires its own unique device number, which is either 8, 9, 10 or 11. Device numbers can be set in a variety of ways, including software, dip switches, as we can see with this Accelerator Plus, or a little bit more intrusively, using the Commodore 1541 as an example, cutting traces on the actual circuit board. As the default device number is 8, cutting tracer J2 adds 2 to this number, which now means this Commodore 1541 is device number 10. Now we've configured our devices, it's now time to confirm the computers we're going to use, which in this case are my restored VIC-20 and Commodore 64. Having explored the VIC switch's user manual, there are 2 interesting areas that I'd like to explore further. The first one is, can the VIC switch manage queuing requests? So I think we can test that with multiple devices and multiple computers. And the other is the recommendation to turn the VIC switch on last. And an interesting article on C64 Wiki regarding burst mode. So with that, let's see what we've got on our testing guide. Having chosen Doom and Hero for the VIC-20, Commando and Rambo for the Commodore 64, I've also selected a VIC-20 15K basic program to do some benchmark testing. Having downloaded the necessary files from the internet and moved them over to the SD card, it was now time to use FB64 DRA copy and D64-IT to copy them over to an actual 5¼ inch disc. And the VIC-20's DIR Plus to navigate and load files. In line with our testing guide, let's perform some pre-VIC-switch fast load benchmark testing in line with the comments regarding burst mode incompatibility. And the results from left to right, the SD to IEC saw a 10 times improvement, the Accelerator Plus half that at 5 times, however the 1541 saw no performance improvement at all. Having connected the Commodore 64 to the VIC-switch input 1 and the VIC-20 to input 8, and in preparation for the VIC-20, despite having numerous VIC-20 RAM upgrade cartridges, as Hero and Doom required over 30k each, I resulted in using the fantastic penultimate cartridge. Being careful to power on the devices before the computers and the computers before the VIC switch, we still encountered an issue with port 1, which means it probably didn't put enough deoxit in there. As the Commodore 64 was unable to communicate with the VIC switch via port 1, for a quick resolution I've moved the ports from 1 to 2 and 8 to 7. Checking back to our testing guide, we can see the next test is the single device to single computer. So let's grab a copy of Commando Arcade for the Commodore 64 and let's see how the VIC switch handles this via the 1541. This test has identified the VIC switch can proxy send and receive data, in this case from a 1541 floppy disk drive device. The next test is to load from two separate devices. So in this case, let's load up the Hero D64 image for the VIC-20 via DIR Plus on the SD2I-EC. Now selecting Unit 9, which is the device number for the Accelerator Plus, we can now load the boot code for Hero. It's now time to queue files from multiple devices to multiple computers. So preparing Rambo for the C64 on the 1541. Let's load up the VIC-20's file browser and load the boot code for Doom. Whilst Doom is loading, let's fire up Rambo on the C64 and see how the VIC switch handles multiple requests. So we've just seen the Commodore 64 receive its directory listing, and then the VIC switch handed control back to the VIC-20 to carry on loading Doom. Again, the VIC switch has served the Commodore 64's request and then handed it back over to the VIC-20. It's now time to check to see if the VIC switch will work even though it's not powered on last and if a cable is removed. Powering the VIC switch up first, we can see LED 1 flicker briefly, as seen before. But curiously, LED 2 configured to the C64 remains on. When powering up the C64, LED 2 is cleared, and a quick C64 disk check shows the VIC switch remains operational. Moving on to the VIC-20, powering that up enables LED 7, but a second later this is also cleared. And again, the VIC switch remains operational. In this test, we're checking to see if the VIC switch is still serving the C64. And we'll do the same check for the VIC-20. And now we're going to turn off the VIC-20 and pull the comms cable out, putting it back in and rebooting the VIC-20. A quick check shows that the VIC switch is still serving the VIC-20. And the final test, in line with the burst mode comments, we're going to test the fast load cartridge when using the VIC switch. Although Commodore's original intent was to provide a higher speed bus, due to a VIC-20 chip bug and C64 aggressive release schedules, engineers were unable to provide a timely fix. In 1984, American software company Epyx developed the FastLoad cartridge, which allows faster data transfer over the serial bus. So testing the original cartridge and a more recent one, it showed the VIC switch was not compatible with FastLoad. So having completed all of our tests in line with the testing guide, it was time to go through our findings. Regarding device access and queuing of devices across multiple computers, we managed to prove this with VicDoom and Commodore 64 Rambo, which proved the point really well. So that's a yes. Regarding power on order, the VIC switch was able to serve the C64 and VIC-20 both when powered on first or later, including the removal of the IEC cable from the VIC-20. So again, this is a yes. Regarding the reference to burst mode, our testing with the FastLoad cartridges has proved the VIC switch is not compatible with burst mode or FastLoad. One interesting observation is when trying to load a file via the VIC switch from a basic program, the disk drives appear to go in an endless seek. Having tested a Commodore 128, once you've inserted the FastLoad cartridge, it defaults to Commodore 64 mode, and benchmark testing proved to be the same as a Commodore 64. It was a similar story for the Commodore 128D and CR. When using the FastLoad cartridge, it defaulted to Commodore 64 mode and loaded the benchmark program from the internal 1571 drive in 8 seconds, which is the same as the Accelerator Plus when using the FastLoad cartridge. As a result, we can now conclude the VIC switch queues multiple computer device requests efficiently. It operates irrespective of when it's powered on or if the transfer cable is removed. And finally, the VIC switch does not support faster loading speeds. At the end, as always, it's time to play some games. So let's have a look at some of the games we've featured in this video for the VIC-20 on Commodore 64.